in environmental and water resources engineering are exciting, challenging, and contribute to society. In this video, you will see some of the lab experiments engineering students conduct in their classes, during summer camps, and for independent research. You will hear engineering students' unscripted answers to real questions that you may have about this exciting career choice.
Sedimentation experiment represents a riverbed, and we use different shapes of bridge piers. We have the circular, rounded, and rectangular bridge piers, and they produce different amounts of scouring. Scouring occurs when sand is removed around the base of the bridge pier.
The circular pier produces the least amount of scour, but is not necessarily the most economical. The rounded pier produces a moderate amount of scour and is more economical than the circular pier. The rectangular pier produces the most scour and is the most economical.
We create something which is not there. That means we design and construct structures.
If you're looking at the environmental side, you got jobs in water treatment plants, water supply, maybe collection systems like sanitary and sewer systems, and so on. And if you're looking at the water resources side, you got design and construction of dams, weirs, channels, spillways, canals.
I like the part about getting outside and working with the projects rather than sitting in an office all day.
I found that doing group project is the most exciting part of being in engineering. And because I found that I get to meet a lot of people and I can discuss with them how things work in real life.
First thing we did was we took a field meter and we dropped it into the water, set a probe on the end of a cord, and we put it at different depths in the campus lake to be able to determine where the dissolved oxygen was and how it changed with different depths in the lake. We wanted to measure the dissolved oxygen because we wanted to identify the middle region of the lake, which is called the thermocline. And this region is where an engineer would want to design an intake pipe for a drinking water facility.
I'm looking at a problem which has occurred after the construction of dams on the Illinois River.
I would like to go on to pursue a master's degree in environmental engineering so I could research water pollution.
I'm most interested in groundwater mediation, but I also enjoy collection systems as far as storm sewer collection and design.
What I hope my research leads to is more efficient methods of cleaning up oil spills that have contaminated groundwater.
My older brother, who's 7 years older than me, he's actually an aeronautical engineer. So my family and I decided to just look into engineering, and I chose civil engineering.
My great-grandfather was a civil engineer working for the Army Corps of Engineers. He worked on the Mississippi River around the St. Louis region. And from then on, it just kind of sparked my interest. I always loved being outdoors.
I decided I wanted to be in engineering in high school because I always enjoyed my math and science classes.
I always wanted to be an engineer. Right from a young age, I was extremely interested in math and science, solving various kinds of problems, and also being able to involve with new kinds of designs, analysis. So the only thing I was looking up for was to being an engineer.
I had a doll. Her name was Chatty Patty, and when you put different things into her hand, she would tell you what it was, and I always wondered, well, how did she know she's not real? So I found some tools my mother had laying around, and I took her apart to find out. I never really got the answer, but I learned a lot about toys.
This
This experiment is to test to see how much granular activated carbon is needed to remove a sufficient amount of waste dye water from the industry. As the mixture is shaken, the carbon will absorb or remove the dye from the wastewater. Water resource engineering is important to today's world because we need a good supply of drinking water.
There's always going to be jobs for water resources engineers. Our natural resources as far as fresh water is limited, so we have to be able to plan accordingly for the future.
If you're looking at the environmental side, you got jobs in water treatment plants, water supply, maybe collection systems like sanitary and sewer systems, and so on. And if you're looking at the water resources side, you got design and construction of dams, weirs, channels, spillways, canals. So they're pretty good opportunities. I'm interested in doing any one of these.
The type of job engineers expect could be office work like designs, where one spends most of the time in office designing and computing different parts of the engineering structures, and the other could be on-site, that means supervision of construction.
Job outlook looks pretty good right now. There's plenty of jobs out there for environmental and civil engineers and water resources and environmental engineering. Every day I check and there's more jobs posted on the internet, so there's definitely a place out there for everyone.
My research is on cleaning up oil spills in the groundwater. The reason that we're dyeing the gasoline red is so that it can be seen in the tank. Once the gasoline has been poured into the tank, I experiment with injected solutions to move the gasoline from a larger area to a smaller area where it can be pumped out of the ground. Most of the time in here is just waiting time. Things happen slowly. You have to just sit here, wait, write down what happens as it happens. I take pictures at different time intervals to help document the movement of gasoline. What I hope my research leads to is, instead of completely digging up the ground to clean up oil spills, we would just put in a well and pump the contaminated fluid to that well where it can be cleaned up.
I'm hoping to get a field engineering job so that I can apply what I learned in class.
Eventually, I want to just be a professor. I liked engineering, and I think more people could appreciate it if it's taught the right way.
I'm basically looking into the construction and design of dams, basically how to tap the natural water resources and probably able to provide the most feasible and economical design for a dam.
I hope to get a job in environmental engineering with a consulting firm, working on as many projects as I can, anything from collection system design to water and wastewater treatment plant design, working out in the field, getting outside, getting my hands dirty, and getting the work done.
Altogether, my ideal job would be one that I would love going to, learn something new every day, and gain experience as I go along.
In environmental engineering, there are many job opportunities for people with bachelor's degrees, such as working for the EPA, working at a water treatment facility, and water testing.
You can work for the state, you can also work for an engineering firm. You don't have to exactly get a master's to be able to work in an engineering department.
The more you look around, it really doesn't matter whether you have a master's degree or a bachelor's degree. Both of them are very useful in the civil engineering, environmental engineering world. It just depends on how high you want to go in the company, whether you choose to go and get a master's degree or a PhD in the field.
A hydraulic jump is a phenomena in fluid mechanics which occurs where a fluid or a liquid flowing at a higher velocity discharges into low velocity area, and at which time the water level abruptly rises. There will be turbulence in the flow, and a lot of energy will be dissipated during the process. Students ask how the jump is formed and what is the reason behind the moving the jump from downstream to upstream. They are curious to know the reason behind this phenomenon.
How I take it as being a geek is you're always studying, you don't have a social life, and I must admit, I do study a lot, but I do definitely have a social life as well.
I play sports. I always have played sports. I don't know if I'm considered a geek or not. I don't really care.
Some engineers are geeks, but you see a lot of interesting people from a lot of different backgrounds, and it's just a great field to be in. You're not centralized into one area of expertise or in one side of the world, so you get to see all kinds of nationalities, people from different expertise, different sides of engineering, and you get to do a lot of interacting with a lot of other groups of engineers.
Engineering is what you make of it, so if you're a geek when you went into engineering, then you're going to be a geek who's an engineer. If you're somebody who was cool who went into engineering, then you're going to be a cool engineer. So it's just who you are before you go into engineering. That's who you're going to be when you become an engineer.
It's hard work, but if you come up with the attitude that, you know, you can do it, you can do it. My advice would stick with it.
Well, it's not a matter of being difficult or hard, it's just accepting the challenge and doing whatever it takes to finish that challenge.
First of all, engineering is hard, but you just have to fight through the tough times to get to the good times of it. Engineering is a great field to be in, it's a very fun field to be in, but it's also challenging. If it was easy, then everybody would be an engineer.
As long as you are interested in engineering, and nothing is impossible to achieve as long as you put your mind into it.
Any engineer that you talk to, they don't know everything. The important thing is to know where to look for the answer.
Oil spills in water provide a major environmental cleanup challenge. In general, the oil will float on the water and spread out over a large area. The ecosystem is threatened as oil covers fish and fowl and disrupts the beauty and balance of nature. The technology for the recovery of oil and the remediation of the environment begins in a lab. In this lab, we simulated many aspects of an actual oil spill. We tried various bench-scaled methods to remove and recover red dye oil that was spilled in a beaker of water. We also calculated the cost of disposal of contaminated materials, labor, equipment, and site management.
High school students should take as many math and science classes as they can. For environmental engineering, chemistry is also really important.
Most of the engineering courses require mathematics, therefore they have to be good at in mathematics and also related sciences like physics.
If that's one of your goals to become an engineer, don't get frustrated. Don't let anybody tell you you can't do it, because you can. There's no reason why you shouldn't go after that.
I would say just do it and work hard, believe in yourself.